My main 3D printer is painfully slow, and frankly, it barely prints well. Most people will throw it out or spend weeks upgrading the parts. Instead, I started my NeckGuardian project with this same 3D printer anyways. I didn't try to rush it. I'm taking small micro steps this week, keeping things consistent and slow so that I don't burn out. And by tweaking the custom slicer settings, I managed to get crisp, fast printing out of the machine that has no business of outputting erratic precision, slow and steady wins this week. The part list to print this week is extensive. As we have simulated all the parts, the bed where the servo will be mounted, the spooler that will be mounted on the servo, and the spooler limiters that will be attached to the spooler and will be hitting the limit switch, and then finally the vertebrae. Let's talk about the spooler. Because this machine was so slow, I had to configure it in such a way that we'll find the sweet spot between the accuracy and the speed. I tuned multiple times the acceleration and the flow rates specifically to be able to print faster without losing the accuracy, which I needed. Also, the helical grooves needed to be printed without the supports, and that has taken many iterations. When you work with the hardware that wants to fail, you do not fight it, you calibrate it. After the spooler, the hardest part was the vertebrae because it has a curved surface that needed to be printed well. And as we know, in 3D printing, the curved faces are printed as steps. To get away with that, I have utilized the configuration of variable layering that helped me print the vertebrae parts smoothly. The configuration basically takes care of the variable layering by this interface, and there I would be able to configure where I want the layers to be smoother and where I don't. I also would be able to select the automated variable layering by which it can be optimized automatically for the print time versus the accuracy and the finishing. Look at this example. One is having the steps and another is smooth. You can easily make out the difference. With the parts off the bed, the next step to check the assembly and check the clearance between them. I dropped the servo in the base plate and checked if it can be screwed easily. I screwed it, and then now is the next time for attaching the spooler. And then comes the limiter. I have not glued the limiters on the spooler because I am living with my kid and this is not safe. I don't have the window which I will be able to use for sticking. I'll find a window and glue it later. So that's why the week 32 stands. It's not the flashy update. No reinforcement learning agent is running it, and nothing is moving under power. It's just physically a plastic old hardware and carefully calibrated. By keeping my stuff small and avoiding the burnout, I'm getting close to matching the physical assembly with the simulation we built weeks ago. Next week, we push further into the full assembly. Small steps, real hardware, and zero burnout. Strive to follow the full assembly, wire up and control loop, or we may have 3D printed iterations again to check the clearance.